Welcome to the DIY Honda Garage channel. The error code P1157 refers to an issue with the air fuel sensor, also known as sensor 1, specifically indicating a high voltage condition in the AFS circuit. This sensor plays a crucial role in measuring the air-fuel mixture entering the engine, allowing the engine control module, ECM, to adjust fuel delivery accordingly for optimal performance and emissions. In the Honda Accord from 2012 to 2017, this sensor is typically located on the exhaust manifold or very close to it, ensuring that it can effectively monitor the air-fuel ratio before the exhaust gases enter the catalytic converter. High voltage in this circuit might suggest a problem with either the sensor itself, its wiring, or even the engine control module, ECM. It is essential to complete a thorough diagnostic to avoid further issues that might arise from incorrect air-fuel mixture readings. Preventive maintenance is essential to keep the AF sensor and its circuits functioning optimally and to minimize the potential for issues like DTC P1157 from occurring. Regularly inspecting the wiring connecting the AF sensor, PCM, and PGM-FI relay can help identify wear and tear before they lead to serious problems. Ensuring that all connectors are clean and free of corrosion can significantly influence the reliability of electrical signals sent to the PCM. Utilize quality replacement parts whenever sensor components need to be replaced, as substandard parts may lead to early failures. Following these maintenance tips can ensure better performance and longevity of the air-fuel management system, keeping the vehicle in good shape and reducing the risk of encountering error codes. Investing time in preventive measures ultimately saves on future repair costs and enhances vehicle efficiency. In conclusion, DTC P1157 revolves around the A filter sensor, sensor 1, and denotes a high voltage issue in the AFS circuit. Proper understanding of the sensor's role in monitoring air-fuel mixture and how it interacts with the PCM is key to effective diagnostics and repair. Systematic troubleshooting involves verifying the electrical integrity of the related circuits through a series of defined checks that include exploring wiring, connections, and ultimately, the sensor itself. Following each step methodically ensures no issues are overlooked. Repair verification is crucial to confirm that the issue has been resolved, preventing further recurrence of the DTC. Adopting a preventive maintenance routine can also contribute to the long-term health of the vehicle's engine management system, offering peace of mind for future drives. The DTC P1157 signifies a high voltage error in the AF sensor 1 circuit. The AF sensor, located near the exhaust manifold, is instrumental in determining the air-fuel ratio, which is critical for engine efficiency. It sends this data to the PCM, or powertrain control module, allowing for real-time adjustments in fuel injection. If the voltage from this sensor is too high, it could indicate wiring issues, a fault in the sensor itself, or even malfunctioning modules such as the PCM or the PGM-FI sub-relay. Additionally, the freeze frame data attached to this DTC provides a snapshot of vehicle conditions at the time of the error, which can be invaluable for diagnostics. Correctly locating and understanding the components involved is vital in effectively addressing the issue. The potential causes for DTC P1157 are primarily related to wiring and sensor integrity. An open circuit in the AFS Plus wire, which is responsible for positive voltage, can lead to failure in readings, causing high voltage errors. Similarly, an open circuit in the AFS minus wire, meant for negative voltage, can similarly affect sensor operation and lead to the same DTC. Additionally, the AFS sensor itself might be faulty or have a manufacturing defect, necessitating replacement. It's critical to verify voltage supply and ground integrity to ensure that the sensor is receiving the correct signals. Moreover, wiring issues such as frays, shorts, or disconnections can also lead to false high-voltage readings in the circuit. The manifestation of DTC P1157 may result in several observable symptoms. First and foremost, drivers might experience poor fuel economy, as incorrect air-fuel mixture settings can lead to inefficient combustion. Additionally, engine performance may become rough or inconsistent, as the engine struggles to optimize its fuel delivery based on inaccurate sensor readings. Lastly, the vehicle's check engine light will likely illuminate, alerting the driver to a potential issue that needs attention. It's vital to pay attention to these symptoms, as they not only indicate a problem with the air-fuel system, but may also lead to more severe engine issues if not addressed promptly. Addressing these symptoms sooner rather than later can not only improve vehicle performance, but also efficiency. The first step in troubleshooting DTC P1157 involves a basic verification process. Begin by turning the ignition switch to the on position, which powers the vehicle's electronics without starting the engine. Next, utilize the Honda Diagnostic System, HDS, to clear the DTC temporarily from the system memory. This will allow for a fresh diagnostic session. Then, start the engine and let it idle for 1 minute. After this brief wait, check for any pending or confirmed DTCs using the HDS again. This process is vital for verifying whether the problem persists. If DTC P1157 is confirmed and reappears, the fault must be further investigated. If not, this may indicate an intermittent issue, warranting checks for loose connections or fault in wiring before proceeding. In the second step, you will perform an open wire check for the AFS plus line. Start by turning the ignition switch to the lock position to ensure all systems are off. Next, connect the HDS to jump the SCS line to prevent accidental triggering during your checks. Disconnect the AFS sensor's 4P connector and the PCM-C connector to isolate the circuits. After disconnection, check for continuity between the two designated test points, the AFS sensor 4P connector at pin 2 and the PCM connector C at pin 48. Ensuring continuity means there's a proper path for electrical signals. If continuity exists, the AFS Plus wire is functioning correctly, and you can continue to the next troubleshooting step. Otherwise, repair any identified issues in the wiring. The third troubleshooting step involves checking the AFS- wire for continuity in a similar manner as the AFS Plus check. Once again, ensure the ignition is in the lock position and that the connectors from both the AFS sensor and PCM are disconnected. This time, continuity will be checked between the AFS sensor 4P connector pin 1 and the PCM connector C pin 47. If continuity is confirmed, this validates that the AFS- wire is intact and functional. If not, it's necessary to locate and repair any breaks or issues within this wire. The AFS- wire is critical for completing the sensor circuit, and addressing any faults here is key to resolving the DTC issue effectively. Next in the troubleshooting process is to check the AF sensor itself through substitution. First, replace the original AF sensor, sensor 1, with a known good component that's confirmed to be functioning properly. Once the new sensor is in place, carefully reconnect all previously disconnected connectors, ensuring that there are no loose or faulty contacts. With everything reconnected, turn the ignition to the on position to prepare for the next step, which is resetting the PCM. This should be done using the HDS to clear any old data, and after that, perform the PCM idle learn procedure. Doing so allows the PCM to recalibrate to the new sensor, eliminating any possible residual issues. At this point, Check for any new pending or confirmed DTCs with the HDS to see if the problem has been resolved. In the final stage of verification, it is crucial to reaffirm that all wiring and connectors are properly reconnected after the repairs. Begin by ensuring all connectors are securely in place and that no wires are pinched or damaged. Switch the ignition back to the on position and utilize the HDS once more to check for any pending or confirmed DTCs. If DTC P1157 still appears, it indicates that further investigation is required. Check for any loose terminals or poor connections specifically in the AF sensor wiring, PGM-FI subrelay, and the PCM. If the PCM was previously updated, consider substituting it again to eliminate any chance of using outdated software. The objective here is to ensure the system is entirely operational with no further diagnostic trouble codes. Use this step to confirm the integrity and performance of all related components. Please like and subscribe to the channel. See you next time.